Hello friends, welcome to another video of Zeta Axis, and today we are streaming live for the first time, and today I will try to see all my different connections. So here are different interactive options that you can use to interact with me. You can use exclamation question to ask questions which will be displayed here and for some time, and then it will be stored in our database where we can access it later to discuss your questions. So do ask questions, and we will also have some polls within this video, so we will keep this interaction live. So let's start. Today we will discuss the chapter 14th of G.C. Leong book about climate, and this is the second video in this part because the chapter was very long. We have divided the chapter into two parts, so this is the second part of that video. The first part is already available. So the first thing that G.C. Leong discusses is pressure belts. In our different videos, we have already discussed in detail what is pressure belts and how they are caused. Here, we will be discussing them briefly. So here, you can see that these are the permanent winds, and these are the pressure belt areas. Here we can see that there is convergence zone of these two wind systems. So here we have one pressure belt. This is a low pressure belt. Here we see that there is this permanent wind which is moving northwards, and here is this permanent wind which is moving towards the equator. So here we have another high pressure belt, and similarly over here we see low pressure belt. So these regions, they permanently experience either low pressure or high pressure. So these are called pressure belts. So let's see the characteristics of the pressure belts. The first is equatorial low pressure belt. What is an equatorial low pressure belt? We see that this is our equator over here. You can see this is the side view. Here you can see this is the equator, and over here there is Hadley cell where the wind is coming from the subtropical region towards the equator. Wind from northern hemisphere as well as southern hemisphere, they come over here, they merge over here and they rise. So this region has low pressure because air is moving out of this region, it is moving up, and because of there is a decrease in pressure, and that is why this region has permanent low pressure. Here we can see this wind system. The wind is moving from the high pressure region towards this low pressure region from both hemispheres, then rising up, hence creating a low pressure. So what are the characteristics of this low pressure belt? So here we can see that it is between 5 degree north and south. It is situated between the 5 degree latitude north and 5 degree latitude south. So this is the approximate location. It varies based on the season. It is created because of intense heating due to direct sun rays. So we know that this is the equator over which the sun is directly focusing its rays, and therefore it is heated. And because it is heated, the air will rise up. The air rises up, therefore it creates a low pressure region. So here air ascends because it is heated by the direct sunlight. Warm air is lighter and it expands. There is also centrifugal force. Centrifugal force is maximum on the equator. Therefore, this centrifugal force also aids in the rising air. Therefore, we see that air continuously rises up in this region, creating a permanent low pressure region. And this is felt all across the globe. So along the equator, throughout the year, we experience a low pressure region. Now, this region is also called as doldrums. Reason is that air blows very slowly on the surface over here. So the winds, they are coming from both the directions, from both northern hemisphere and southern hemisphere, and they are merging over here. Now here the air is moving very slowly. So slowly that even the ships, they find it difficult to move over here. And that is why it was called doldrums. Air blows very slowly on the surface in this region. And it is zone of convergence. So we can see it is called zone of convergence because air from both northern and southern hemisphere meet in this region. Easterlies from two hemispheres meet here, therefore it is called zone of convergence. Now let's see the second pressure belt, that is subtropical high pressure belt. And if we see in this video, then we will see that subtropical high pressure belt is located over here. It is located at the intersection of Hadley cell and Ferrel cell, and here we can see that air is descending. At the low pressure belt at the equator, the air is rising up, but over here it is descending. So because of this, we have a continuous high pressure because the air is descending, air is aiding or coming in this region. Therefore, the total amount of air is increasing, and therefore we see that there is net increase in the amount of air, and therefore there is this high pressure over this region. If you see the characteristics, then so if we see the characteristics of subtropical high pressure belt, then it is around 30° north and 30° south. So it is located around the 30° latitude in both the hemisphere, and air descends here from upper atmosphere. So basically air from the upper atmosphere will come towards the surface, and that is why it is a zone of divergence. It is called zone of divergence because the air over here is moving away. So the air which is descending over here, it is moving in both the directions. One part will move towards the equator, other part will move towards the polar regions. Therefore, it is called zone of divergence. And because the air is descending, we know that the air will get adiabatically heated. The air which is adiabatically heated is dry. Reason is that its temperature increases. When its temperature increases, its moisture carrying capacity increases. Therefore, relative humidity decreases, and that is why air is dry, winds are calm and light. So here, because air is descending, remember that descending air will not give you any rainfall, and therefore we have dry region in this. There is very little rainfall in this region. In fact, most of the deserts are located in this high pressure belt region in both hemispheres. This belt is also called as horse latitude. The reason is that because the air moves in this region very slowly. So in olden days, the traders, they would move their horses into the sea to make the boat lighter so that they can move, and that is why it was called horse latitude. Next pressure belt is temperate low pressure belts. So here we see that the temperate low pressure belt is located over this region here. It is at the intersection of polar cell and Ferrel cell, and here we can see that polar cell and Ferrel cell, they are ascending up. So here again the air from both the sides is meeting and rising up. So if we see the characteristics, we can clearly see that it is a zone of convergence with cyclonic activity. Now here it is called zone of convergence because air from westerlies as well as polar winds, they converge, and because there is huge temperature difference between both of these airs, it causes cyclonic activity. Therefore, on this margin, on the temperate low pressure belt, we see lot of cyclonic activity. They are best developed over oceans. So over oceans, we see the best characteristics of these pressure belts. Over the land, there are characteristics, or they are not very distinctive, but they are very distinctive over the oceans, and the reason is that summer and winter temperature difference is very low over the oceans. What happens over the land, that during the summer the temperature is very high, while during the winter the temperature is very low. Therefore, we do not see this low pressure belt distinctly over the land because the local characteristics, they will overcome this property. But over the oceans, the temperature difference between summer and winter is not very high. Therefore, it is very distinctly seen over the oceans. Next is the polar high pressure belt. So over this polar region over here, there is a permanent high pressure region. Now this may not be a belt. It is a particular region at the poles where you have permanent high pressure. The reason is that the air which is rising in the subpolar region, in the polar cell, it comes over here, it it is very cold, it is very heavy, so it will start to descend. And when it descends over here, it creates a high pressure region. We know that when the air is descending, air is accumulating in that region, therefore it is creating a high pressure. Even though air does move out of here, but because the cycle is going on and the air is descending over here, you will see a high pressure over here. If we see the characteristics, we can see that it is situated at north and south poles at 90° north and south, and it is caused due to permanent cold temperatures. So at the poles we have permanent cold temperatures, and because of that permanent cold temperatures we see this polar high pressure belt in this region. So here is a question for you. The question asks that which of the statement regarding doldrums is true. So these are the four options that you can see, that doldrums are located on or close to equator, doldrums are located in the region of convergence or trade winds, and they are very strong winds blow in doldrums. Doldrums are seen in summer season. So these are the four statements and these are the options. So I will start a poll where you can answer this question. So you can see that if you feel that A is the right answer, then you can use this exclamation option A. If you think that B is the right answer, then you can use exclamation option B. If C is the right answer according to you, then you can use exclamation option C. And if D is the right answer, then you can use exclamation option OPT D in your chat. So if you type, your answer will be noted down and this will be permanently stored. So we will be tracking your answer tracks, that what you have answered so far. I guess there are not many people over here. You have to type exclamation OPTA like this to answer it. You have to use this term. And you can check your answers, you can check your complete scores in this session as well as overall by using exclamation option. So all these things you can see in this bar over here, whichever commands are available to you. Here you can see exclamation opt is for opting for these questions. So here is our next slide. We also have a second question over here. So here you can see which of the statement regarding subtropical high pressure belt is true. It is located around 30° north and south. It is in zone of convergence. There is heavy precipitation in this region and it is called horse latitude. So I will start the option. If you answer right, you will find your name over here. So use these terms, whichever option you feel is right among these, you can select them from here. And if you have any questions, you can use exclamation question and then type your question. We have 30 seconds left for voting. Use these options, right? Someone has voted option C, so we see that there is one vote for option C. Remember, there will be some lag, so try to vote before 10 seconds or 20 seconds that are remaining in the clock over here, and you can see that the answer is option D. Now why it is option D? If you see option C, it is 1 and 4, so it is located around, yeah, I think I have input it wrong. You are right, the answer is C. There is some mistake from my side. I am also learning. This is my first live stream, so I will try to improve on that. Now let's get back to our lecture. So here is our planetary wind systems. So the next topic that is discussed in GC Leon chapter 14 is planetary wind system. So we know that winds, they tend to move from high pressure belt to low pressure belt. Here if we see this diagram of our trade winds, we can of our permanent winds, we can clearly see these are our low pressure belt, these are our high pressure belt, and this is again low pressure belt. So air moves from the high pressure belt towards the low pressure belt. That is one of the very obvious things, but do keep in mind that all these wind systems, they are moving actually from a high pressure belt towards the low pressure belt. So the first important thing over here is winds tend to move from high pressure belts to low pressure belt. Now rotation of earth, it produces Coriolis force. We have made a very extended video on this. I will not be going in detail on this Coriolis force, but will be discussing only in brief. So rotation of earth produces Coriolis force. Here in this diagram we can see the effect of Coriolis force. We can see that one stream of air is moving in the north, in the northern hemisphere. Now because of the Coriolis force, it will be deflected in the right side. Remember, when you are checking the left and right side, you should be facing in the direction of the wind. So here, if you face in the direction of the wind, we will see that in the northern hemisphere, it is deflected in the right hand side. While the wind which is coming from the pole towards the equator, again, if you face in the direction of the wind, that would be something like this, then it is again deflected in the right side. So this is for the northern hemisphere. And in the southern hemisphere, if you will see, the wind which is moving from the equator towards the pole, it is getting deflected in the left side. Remember, you have to face in the direction of the wind. And again over here, it is getting deflected in the left side. So the Coriolis force deflects the winds. In northern hemisphere, it is deflected towards the right, and in southern hemisphere, it is deflected towards left. And this thing is called Ferrel's law of deflection. Remember, Coriolis force is absent on the equator, and it increases as your distance increases from the equator. So if you are at the equator, the Coriolis force will be 0. But as you move away from the equator in both the hemispheres, the amount of Coriolis force will increase. That is, the amount of deflection will increase. Now remember one thing, that Coriolis force, it causes deflection. It does not change the velocity of the air or water. It will only deflect, it will only change the direction. And the Coriolis force is 0 at the equator, while maximum at the poles. Next, we are seeing these east trade winds. These are our trade winds over here. They are moving from this low pressure belt, that is high pressure belt, towards this low pressure region. So we can see in both the hemisphere there are these trade winds which are moving towards the low pressure region at the equator. So these are the trade winds. They are moving from the eastern direction towards the west. So a wind system is always named from the direction from which it is coming. So these winds are coming from the east towards west, and that is why they are called easterlies or east trade winds. Here if we see, these are the westerlies because they move from the western direction towards the eastern direction. That is why these are called westerlies and these are called east trade winds. Generally they are called trade winds. Now if we see the characteristics, then we can see that winds blowing from subtropical high pressure to equatorial low pressure. So they move from this high pressure, subtropical high pressure, towards this equatorial low pressure region. It is a very regular wind pattern and it blows in constant direction with force. So these are a very constant wind forces which continuously flow throughout the year in the same direction. That is why they are very important. These winds, they help traders in high seas and hence they are called trade winds. So in the earlier days, the traders would use their knowledge of these winds for going from one place to another, and that is why they got their name as trade winds, because it helped in trade. They blow from subtropics towards equator. So remember, they are blowing from these subtropical region towards the equator region. They have high moisture carrying capacity because they are warmer air. They are warmer compared to all other wind systems. That is why they have very high wind carrying capacity, and that is why they give lot of rainfall. they are onshore or eastern margin of continents. So if we see these trade winds over here, and if we see the continent, if we see the continent of Africa, so we will see that on the eastern margin of Africa, wind is onshore, that is, wind is moving from ocean towards the land. And we know that because it has very high moisture carrying capacity, which we have already discussed, so it will bring a lot of moisture from the ocean towards the land, and hence giving a lot of rainfall in these regions. So all these regions in this belt, that is in these regions which are on the eastern side or eastern margin of the continents, they will have very high rainfall because the trade winds, they are moving from the ocean towards the land. But if we go to the western margin, then we see on the western margin the easterlies are offshore winds. So here if we see, they are moving right from this ocean towards the continent, they cross the continent and then they reach the western margin. So over the continent they lose all their moisture, and that is why when they reach on the western regions, they do not have much moisture to give rainfall. And that is why you will see that all these western margins, they have deserts. So here we have desert, we have Atacama desert over here, here also we have desert, here you can see there is Sahara desert, here we have Mojave desert. So all the western margin of the continents in this region, they have this desert like situation because of both the continental effect as well as the high pressure belt in these regions. Next permanent wind is the westerlies. Now the westerlies blow from the subtropical high pressure belt to temperate low pressure. Remember, the winds, they blow from high pressure region towards the low pressure region. So now it is moving from this high pressure belt towards this low pressure belt. And again, because of Coriolis force, it is deflected. Here we see that it is in the form of a straight line, but in reality it is in the form of a little curved line because of the Coriolis force. So this Coriolis force, it curves these winds. It is in the southwestern direction in northern hemisphere. So we can see that these winds, these orange color winds, are the westerlies, and they are moving from southwestern direction. So a person is experiencing it coming from the southwestern direction, and it is because it is from the western direction, it is called westerlies. And in the southern hemisphere, remember, it will change, it is from the northwestern direction. So here these winds, they are moving from this high pressure belt towards this low pressure belt. Therefore, the direction is northwestern. They are more variable in the northern hemisphere, and the reason is that because of large land mass having varied topography in northern hemisphere. So these winds, these westerlies, they have very high variability in the northern hemisphere, and we can see that there is large land mass in these regions compared to the southern hemisphere, where we see that mostly it is oceans over here. Therefore here there is very high uniformity in the flow of the winds, while here there is lot of variability, that is, there is very much difference from one season to another season. The southern hemisphere oceans are plain and they do not have much variation. So we have seen because of the oceans over here, there is not much variation. Now if you see further characteristics of the westerlies, so westerlies carry warm equatorial water and wind to western coast of temperate lands. So what are temperate lands? Temperate lands are regions in these area. In these latitudes we call temperate region. So on the western margin of the continents, we will see that westerlies will bring rainfall because they are onshore over here. They are moving from the ocean towards the land, and that is why you will see these regions will have rainfall in the westerly zone. They have warming effect. So we can see that they are moving from the subtropical region towards the polar region, and that is why they are bringing the warmer air of the subtropical towards the cool polar region, and that is why they have warming effect. Pressure differences caused by westerlies lead to cyclonic activities in the region. So here there is very huge temperature difference between westerlies and polar winds in both the hemispheres, and that is why there is large amount of cyclonic activity. Here is a map you can see. So you can see that right at the border, at the edge where the westerlies and polar winds meet, we can see large amount of clouds. These clouds are generally formed by the extratropical cyclones. So in both the hemispheres, you can see that because of the merging of the polar winds and the westerlies, because of the cold polar currents and the cold west and warm westerlies, we will see cyclonic activity in these regions. Here is this image. Anticyclones are also formed this region. We will see anticyclones a little later in this video. Again, there are certain further some characteristics of westerlies. So we see that in the southern hemisphere we have seen that it is mostly oceans over which these westerlies move, and because they are moving over the oceans, there is no obstruction, and that is why they move with very high velocity. And that is why in the 40-degree latitude in the southern hemisphere they are called roaring 40s. In the 50-degree latitude, around 50-degree latitude, they are called furious 50s. And when it comes to 60-degree latitude, they are called screaming 60s, because the speed of the wind is increasing. And this is a very continuous wind. And that is why they are given these names by the sailors. So if we see the southern hemisphere around 40 to 60 degree, we see all these three types of winds. Westerlies blow with very high velocity and regularity, so they are continuous. And they are called roaring 40s, furious 50s, and striking or stormy 60s. And these are based on the degree of storminess in the latitudes they blow. So because they are blowing at very high velocity in this particular latitude, that is why they are given these names, and they cause rainfall on the western coast of continents. Obviously, when you are moving from the western direction, you will bring rainfall to the western coast. So whatever continent will come in their way, it will bring rainfall to their western coasts. Another important feature of the westerlies is that they cause this Mediterranean climate. So we have all heard about the Mediterranean climate, and this Mediterranean climate is caused by shifting westerlies. If you see this video, we can clearly see that based on the seasons, our wind belts, they move north as well as they move south. So if you focus in this region, in this particular region, you will see that the westerlies, they are moving south when it is winter in the northern hemisphere, and in the summer of the northern hemisphere you will see that they will move a little northward. So because of this, what happens that there is a very narrow area in this region, in both the hemispheres, in this hemispheres as well, where we will see that the westerlies direction of flow, it changes. Here the wind direction changes. For half of the year you will see westerlies are flowing from the western direction, from the southwestern direction, and for another part of the year you will see that the trade winds are blowing, as you can see in this region. So there is a change in direction of the winds experienced by this region because of this shifting of the wind belts. That is because of this shifting of the wind belts in the particular region where there is difference, it is called Mediterranean climate. It occurs between 30 degree to 40 degree north and south. It is caused by tilted axis of earth. So this shift basically occurs because the earth is rotating on a tilted axis. It is caused by tilted axis of earth. Summer, sun is over Tropic of Cancer, that is summer, the sun is over here, and that is why you will see that the wind belts will move in the northern side. In winter, the sun is over Tropic of Capricorn, that is sun is over here, that is all the wind belts will move towards the southern side, and that is why we see the shifting. Summer, Mediterranean region under offshore trade winds. So in the summer, because these wind belts have moved up, these Mediterranean regions here as well as over here as well as in these regions, you will see that they are under the effect of trade winds, that is these trade winds. These are the easterly flowing trade winds. While in winter, you will see that because it moves in the southern side, you will see that they experience the westerlies. So for half the year, the Mediterranean region will experience the trade winds, and for another half, they will experience the westerlies. That is why it makes a very distinctive type of climate, because in the winter you will see the westerlies, and westerlies are onshore. That is why they are bringing rainfall. Therefore, Mediterranean region will have rainfall in the winter season. Now we come to the third planetary event, that is polar easterlies. and they will blow from polar high pressure region to temperate low pressure region. So we know that at the poles there is this high pressure, which we have seen earlier in this video. So from that polar high pressure, the winds will move towards the temperate low pressure region. These are very cold winds. Obviously, they are coming from the polar region, that is why they are very cold winds, and they come from the tundra region. They are more regular in the southern hemisphere than in northern hemisphere. So because in the southern hemisphere we have mostly oceans in this region, that is why they are very consistent, while in the northern region we have these continents in the polar, that is why there is some variability that is seen in it. Now here is another question. This question is about Coriolis force, and there are some statements. So it says that it is zero at poles and equator. It is caused by magnetic force of earth. Coriolis force increases with increase in velocity of the fluid, that is wind or water. So if the velocity increases, the Coriolis force also increases, and Coriolis force does not change magnitude of velocity of the fluid. So basically it means that Coriolis force will not change the velocity of the fluid. Whichever option you feel, you can select. Here it is. You can use these particular commands. You can type these commands for selecting the options. You have to write exclamation OPTC. So if you are selecting C, then you have to type this exclamation OPTC. Hi Nani, I've seen that you have written C, but for selecting the C option, you have to type this exclamation OPTC. So what is the answer? The answer is C. That is, these two statements are true and all these two statements are false. We have another question, and remember, for if you are selecting this A, then you have to type exclamation OPT and then A. That is how the commands are recognized by the software. If you are typing simply C, it will not be recognized. Which of the statement on westerlies is true? So shift in westerlies cause Mediterranean climate. Westerlies bring rain on eastern margin of continents. Westerlies blow from tropics to subpolar region. Coriolis force does not affect westerlies. So here is your voting. Remember, type this exclamation OPTA, exclamation OPTB if you want to vote. If you have any questions, then you can ask the questions. You can use this command over here that you can see. This is the exclamation question. So if you write in the chat box exclamation question and then write your question, then a pop-up will rise over here where I can see your question. So I can answer them live on the stream. And if I'm not able to answer them live in the stream, then I do record them and I can come back to them later. Okay, time is getting over. I think there are not many people on the stream. The answer is D. So westerlies blows from tropic, but they also cause 3 and 4, 1 and 3. So basically 1, this one is the 1 and this is the 3. So these two statements are right. These 2 and 4 are wrong. Coming back to our lecture, it is about land and sea, breeze and monsoon. So next topic that is discussed in GC on chapter 14 is land and sea breezes and monsoon. So we know that there is land and sea breeze, and they occur due to differential heating of land. During the day, what we see that the land is heated up while the ocean is cooler. Therefore, there is higher pressure over here and lower pressure over here. We know that wind will move from the high pressure region towards the low pressure region. That is why during the day, wind will move from this high pressure region towards this low pressure region, and then air will rise over here. That is why it will create these clouds. So this is called sea breeze. Remember, the winds are named based on the place from which it is coming. So here the wind is coming from the ocean, that is why it is called sea breeze. It is a diurnal process, that is, it occurs during a cycle of a day. So it repeats each day. So during the daytime we have these type of winds, during the night we have these type of winds, then again in the next day we will have these type of winds. So the cycle is diurnal, that is, it occurs every day. It is similar to monsoon, which is seasonal process. So even if you see monsoon, each year there are change in direction of these winds. So it is similar to that, but it occurs every day, while the monsoon they occurs after a year. So here is in detail we can see that land heated rapidly and sea is cooler during the day. Warm air rises over land. We can see that warm air is rising over the land, forming local low pressure over land surface. Sea cooler, therefore high pressure. So here the sea is cooler, therefore there is high pressure. Air moves from cool sea towards land. Therefore the air will move from the sea towards the land, and then it will rise up. So this is our sea breeze. And if we see the next, then it is called land breeze. It occurs during the night. The land is cooler. We know that the land, it radiates heat in high amount. Therefore, it cools very fast. While the oceans, they absorb heat and they retain the heat. Therefore, they are warmer. And that is why now we will see that here, this is cooler, therefore high pressure is over here. This is warmer, therefore low pressure is over here. Wind will move from the high pressure region towards the low pressure region. Thus, wind will move from the land towards the water. It will rise up over here because air is warmer over here, creating clouds and giving rain over the oceans. So if we see it, land cools quickly from local high pressure, so it forms local high pressure over the land. Sea remains warm, forming local low pressure. Air moves from land towards oceans. Fishermen, they know this process, and therefore they take advantage of this wind reversal during the night and day. They sail out, that is, they go into the sea for fishing during the night time because of the land bridge. So during the night time, because the wind is moving away from the coast, they can easily move deeper into the sea, while when they have to return, they return during the daytime because the wind is moving from the ocean towards the land. So remember this. Now next we will see monsoons. We have already discussed monsoon in great detail in a separate video where we have discussed a complete process of Indian monsoon. Here in GC Leong they have discussed it briefly, so we will keep the discussion very short based on the GC Leong book. So the monsoon is caused by differential heating of land in summer and winter. And by this, what do we mean? Here in these videos you could see that the sun is over the Indian subcontinent, so it is heated over here, while here it is away. The sun is located over the Tropic of Capricorn. So you could clearly see that there the land was cooler. Okay, so summer southwest monsoon, because land heated due to overhead sun, creates low pressure over land. We have seen that during the summer the sun is over our Indian subcontinent, it gets heated, therefore the low pressure is created over Indian subcontinent and wind will move from these oceans towards the Indian subcontinent. So land heated due to overhead sun during the summer season, and then it creates low pressure over land. Ocean is cool, creates local high pressure. So the ocean is cool, it creates high pressure, while the land is heated, it creates low pressure. Winds move from ocean towards land. So this is the monsoon, this is the wind pattern in the summer season. That is why we get this rainfall. But what happens when the winter comes? We see that land is cooler as sun is in the southern hemisphere. It is located over here. Therefore, our land is very cool. It cools down faster than the water. Therefore, water is now warmer. Water has low pressure. the wind will now move from land towards the ocean. That is why during the winter we see reversal of the winds. That is what we see, reversal of the winds, and now northeastern winds, that is winds from Himalayas, will blow towards the Indian Ocean. So this is how it is pretty much similar to the land and sea breezes, but it occurs annually, while land and sea breezes, they occur daily. Now let's discuss some local winds. Again, we have made a very detailed video on each local wind, but here we are following whatever discussed in the GC Leon. So it discusses two local winds. One is Fohn and another is Chinook winds. Now both of these winds are basically adiabatic winds, and they are dry winds. They are experienced on the leeward side of the mountains. So here is Fohn and here is this Chinook winds. This is seen in Central Europe. You can see these are the Alp mountains. This is our Italy. So in Fohn wind, what happens, that wind from the Italy side, it will move towards the Central European region because of the pressure differences. Now the wind, it rises up because of the Alps. It will give a lot of rainfall on this leeward side because it is getting adiabatically cooled down. But when it crosses, it will descend to the plains. And we know that when the air will move from the high altitude towards the lower altitude, the pressure increases. It gets adiabatically heated. Once it gets adiabatically heated, the moisture carrying capacity is higher. The relative humidity decreases. Therefore, it will not give rainfall. In fact, it is warmer. So it increases the temperature of this region. Very similar thing occurs for the Chinook winds. Here we can see these are the Rocky Mountains. And the Chinook winds, they start from the coastal region. They will rise up the mountains. They will give rainfall in this region. There will be snowfall in this region. But when they descend in the Great Plains of the North American continent, you will see that here they are adiabatically heated. And because they are adiabatically heated, they will not give any rainfall in this region. They will increase the temperature. Even they will melt the snow or ice in this region. So if you see the characteristics, Fohn wind, it is experienced in the valleys of Northern Alps, especially Switzerland in spring. So here we know that there is Switzerland somewhere over here. So in the valleys of Switzerland, you will see these Fohn winds. Then we have Chinook winds, which are experienced on eastern slopes of Rockies mountains. So these are the Rocky Mountains, and this is the eastern slope of the Rocky Mountains. So where it is experienced, the Chinook is experienced in winter season. Again, there is some detail. We have already discussed this, so we will see one by one. It is seen on the windward side of the mountain. So when these winds are on the windward side, that is over here, and for Chinook over here, so air is rising up the mountain slope, adiabatically cooled. Reduction in pressure causes expansion of air. Remember, at the top the pressure is lower, on the surface the pressure is higher. Therefore, when they are moving up, the pressure is decreasing, which is causing this expansion of the air, that is cooling the air, and therefore they are causing rainfall and snow when this air is rising up. It also carries moisture because it is coming from the ocean. Similarly, over here, it is coming from the ocean, it carries the moisture, it is rising up the mountains, it is getting cooled down. Now on the leeward side of the mountain, that is on these sides, if you will see, then air is descending mountains and it is adiabatically heated due to increasing pressure in the valley, and air is compressed. So here air was expanding, here it is compressed. It raises the temperature of wind, raises temperature of valley, melts snow, and it can also cause avalanche. So remember, both of these winds, they increase the temperature of the region, they melt the snow, and sometimes they can also cause avalanche. The next topic discussed in this chapter is cyclonic activity. And the cyclonic activity can be divided into different types. So the first is division will be from low pressure systems and high pressure systems. So in high pressure system, we know that there is only one, which is called anticyclone. But if you go on the low pressure side, we will see there are tropical cyclones, which are called hurricane and typhoon in different regions. Then there is extratropical cyclone, and then there is tornadoes. Tornadoes are also called whirlwinds or willy bellies in Australia. So we see that these are different types of low pressure cyclonic activities. So we will see each of them briefly one by one. So tropical cyclones, typhoons, hurricanes and tornado, all these are cyclonic activities and they are well developed low pressure regions. So basically these are low pressure regions which are very strong. Therefore, the air will flow violently in it. So because the pressure gradient is so high, in the center of these winds, there is low pressure and the gradient, that is the change in pressure, is very steep. Therefore, air from the surrounding region moves very quickly with a very high velocity in this low pressure region. And that is why they move violently in it. Typhoons, they are called in China Sea, that is over here. So the tropical cyclones here are called typhoons. In the Indian Ocean, that is in our Indian Ocean, Arabian Sea and Bay of Bengal, they are called these tropical cyclones. And in West Indian Islands, in Caribbean, that is over these regions, they are called hurricanes. Tornado is a different type of cyclonic activity, but it is mainly seen in the Guiana lands of West Africa, that is somewhere in these regions, as well as in the southern US, that is over here in the Mississippi region. In USA, the tornadoes are also called whirlwind, while it is called dilly valleys in northwestern Australia. Here is again some specific things that is described in the G.C. Leong book. So typhoons, they occur between 6 degree to 20 degree north and south. The reason is that they require Coriolis force as well as warmer sea surface temperatures. Now, Coriolis force is not strong below 6 degree. That is, from 0 degree to 5 degree, there is almost no Coriolis force. That is why we do not see these tropical cyclones in these regions, that is below 6 degree latitude. Above 20 degree latitude, the sea surface temperature is not that high to create that much moisture to cause this cyclonic activity. Therefore, these cyclonic activities are confined to these regions. They are frequent in July to October. There is wide variability. They can also occur outside these periods. Their size is generally 80 to 300 kilometers. They are generally smaller than extratropical cyclones. So the temperate cyclones, that is the cyclones which occur in the temperate region, they are much larger. They can be like 1,000 kilometers wide, while the tropical cyclones are only 80 to 300 kilometers. They have steeper pressure gradient. So even though they are of shorter distance, the air is moving very high velocity compared to the extratropical cyclone because the pressure gradient is very high. What does pressure gradient mean? So if you see this cyclone, this is the eye of the cyclone, and if we go to the exterior, so from here to here, the pressure change is very high. That is what we mean pressure gradient, that is the rate of change of pressure. So because the rate of change of pressure in a small distance is very high, that is why the winds, they will move with very high velocity and they can blow up to 160 km per hour in these winds. They also cause a lot of rainfall, torrential rainfall. We know that the winds, they move and they carry this moisture. Remember, they are occurring over the oceans where there is large amount of moisture. So these carry these moistures in the upper atmosphere and bring a lot of rainfall. That is why with these cyclonic activities, with these tropical cyclonic activities, we have very heavy torrential rainfalls. Other tropical cyclones, similar characteristics. Slight variation in intensity, duration and locality. So we have seen that there are different names given, but they are generally the same thing. Sometimes there is a difference in the intensity or variation, but by large they are all the same. It's different regions, they are called different things. Hurricane is also very similar to the tropical cyclone or typhoons. It is saying that in the hurricanes there is calm rainless center eye, which is true for actually tropical cyclone and typhoon also. So here you can see this is the central region in both of these. Inside this green region you will see there is this vacant column. So this is called the eye, where the air is not moving with very high velocity. It is moving with very less velocity in this eye of the cyclone. Around eye, winds blow at high velocity. So if we see that just around the eye, the winds are blowing at very high velocity. If you see our video on tropical cyclone, you will see that these tropical cyclones are caused because of balance between the Coriolis force, which is trying to move the air outside, and the pressure gradient, which is trying to move towards this low pressure region at the eye. So it is at the boundary of this eye that both of this pressure they equalize each other, and that is why at the boundary they are moving with very high velocity, but there is no wind inside the eye or inside this column of our tropical cyclone. Remember, this is the cross section of our cyclone. Now let's come to tornado. Tornado is very different than the tropical cyclone. The mechanism is different and the effects are also relatively different. They are very small but very violent tropical and subtropical cyclones, and spiral up at velocities of 800 kilometers per hour. So the speeds could be as high as 800 kilometers. They are very much smaller compared to the tropical cyclones. The tropical cyclones can be 80 kilometer to 300 kilometer, but these can be only of several kilometers. But the pressure gradient is even higher in the tornadoes, and that is why the winds they flow with very high velocity. Here, these red regions are the regions where there is a lot of tornadoes, but you will see that most of the tornadoes occur in these regions, that is in the Mississippi basin of USA, that is over here. So this area is basically known for tornadoes. They are small but very violent tropical and subtropical cyclones. Air spirals up at velocity of 800 km. They appear as dark funnel clouds. So we can see that this is a dark funnel, and at the top end of the funnel there will be this dark clouds. Huge pressure difference in tornadoes. We have seen that the pressure gradient is very high, which causes these high wind velocities. It causes houses to virtually explode because of such high pressure gradient and the wind moving with high velocity. The houses they just explode. Their roofs they just are taken away by the tornado. They can occur anytime, but they are most common in spring. Tornado is most typical of Mississippi basin of USA, that is right over here. Now remember, these tornadoes they are created by wind shear, that is the friction between winds. So winds, when they are moving in different directions, in different layers, they create a shear effect, and that is what creates these tornadoes. They are generally seen where there are these frontal activity going on. Next are the cyclones. These are extratropical cyclones. They are also called depressions, confined to temperate latitudes. So these are confined to the temperate latitudes, and there is a low pressure region in the center, but pressure gradient is high. Size can be 200 to 2500 kilometers. So here you can see an extratropical cyclone, and you can see the size of this extratropical cyclone. You can see that it is comma shaped, and if you will see, then there is very distinctive warm front where there is this cold air and there is warm air. You can see this warm air is moving over the cold air, and again there is this cold front where there is cold air moving towards the warm air. So this is how extratropical cyclone looks like. If you take the cross sections, there is this warm air trapped between the cold air on both sides. Here we can see the extratropical cyclones. We can see the size of the extratropical cyclones compared to the tropical cyclones. These are tropical cyclones, these small ones, and these big ones are the extratropical cyclones. They move not with very high velocity like the tropical cyclones. They can be stationary sometimes, or they could also be moving. Now we will see how this is created. So what are the effects of this approaching tropical cyclone? So there is a fall in pressure. So because they have a low pressure region in them, we will see that there is fall in pressure, dull sky, oppressive air. Dull sky means you will see that there are clouds. So we know that there is this warm front which is moving over here. And because at the front the clouds are formed, we will see that there will be cloudiness, that is dull sky is there. Strong winds are there because there is low pressure region and wind is moving. You can see there is this low pressure region and wind is moving around it. That is why you will see strong winds. Rain or snowfall can occur. So we know that at the warm front as well as at the cold front, the air is rising up, especially at this cold front. The air is rising up at a very high velocity, which will give rainfall, and if there is this freezing climate, then it will give snowfall. As warm tropical air meets cold polar air. So this is basically created at the temperate region where we have these westerlies, they meet the polar currents. So mostly we see that these activities occur at the merger of these two type of winds. That is why we have this warm air which is brought by the westerlies, and this cold air are brought by the polar winds. Winds blow inwards towards low pressure region. So we can see that the wind, there is this low pressure and the wind is moving towards this low pressure region. It is moving in this circular fashion because of the Coriolis force. Remember, this is in the higher latitude where the Coriolis force is higher. Therefore, there is higher deviation even at the lower velocities. And if we see the direction, then in northern hemisphere it is in anti-clockwise side, and in the southern hemisphere it is in clockwise direction. Fronts are formed and they lead to rain, snow and sleet. So we can see these type of fronts are formed in the extratropical cyclones. Now the last topic is anticyclones. So we have seen that anticyclones are high pressure systems. All of the cyclonic activity that we saw, they were low pressure systems, but the anticyclones, they are high pressure systems. These are opposite of cyclones. They have high pressure region in the center because the air is descending, and that is why you will see that there is high pressure. Here we can see an example of this where the air is descending, and this is our anticyclone, this is our cyclone where the air is rising up. This is an example of cyclonic wind, while this is an example of anticyclone. So here the air is descending, it is diverging from the region. Isobars are far apart. Isobars are the lines which indicate the regions having same pressure. So we will see that the pressure gradient is not very high, there is gentle pressure gradient over here. Descending air, it blows outwards from the center. So we have seen here that the descending air is moving away from the center. Blowing air is deflected by the Coriolis force. So here is an example. In this video you can see in the northern hemisphere and southern hemisphere how anticyclones move. The air is moving outwards from this central high pressure region, and then it is deflected by the Coriolis force. Blowing air is deflected by Coriolis force. In the northern hemisphere the direction is clockwise, in southern hemisphere it is anti-clockwise. Winds are light, sky is clear. Because the air is descending, air is getting diabatically heated, so you will not find any rainfall, which is indicated in this figure. Here in the cyclonic activity you can see there are clouds. Here you do not see any clouds because the air is descending, it will not give any rainfall. Clear sky, obviously there is no rainfall, no clouds are formed, so it will be clear sky. Air is calmer in these anticyclones because the pressure gradient is very gentle. That is why air is calm. Air is not moving with very high velocity. Winter intense cooling may cause fog. So in winter, if there is this anticyclone, it could lead to foggy situation because the air is not rising. The moisture is confined to the lower grounds, and if there is sufficient cooling in the region, you will see fog. Anticyclonic conditions last for days or weeks, but they fade out quickly with the change in atmospheric conditions. Now here there is a table where we can see different zones of our earth. Here is the latitude in which these zones are there. Here there are different climate types. These are all the 12 climatic systems which are discussed in the GC Leon. We have already made video on each of these. So this is a basic summary in this table where you can very quickly recall that which type of climate is located in which zone. So here we can see hot, wet, equatorial is located from 0 to 10 degree north and south in the equatorial zone. Tropical monsoon, which is in our India, and tropical marine, which is located in hot zone between 10 degree to 30 degree both in north and southern hemisphere. Rain mainly in summer, 80 centimeter. We have this savanna climate here. So these are the climates. We have already discussed each of this climate in detail, but you can use this table for your reference. If you want, you can take a snapshot over here. Similarly, the next slide we will see, this is also classification. We can see the equatorial region. We have this type of climate, equatorial climate, where we have equatorial rainforest, and this is the type of rainfall pattern over here, and this is the temperature. Temperature is almost constant. The monsoon is almost constant in these regions. We can see there are two peaks because the ITCZ, that is equatorial convergence zone, it crosses the equatorial region twice, once when it is moving north and second when it is moving south. That is why you see two peaks in the monsoon. In the in the hot zone, that is just below the Tropic of Cancer, that is 23.5 degree, you will see there is hot desert climate, and this is on the western side of the continents. Then we have the savanna type climate, and this is the pattern of rainfall and temperature. And then we have the tropical monsoon. We can see that the rainfall is concentrated in few months, temperature is higher. Similarly, we can see other types of climate which are discussed in UC Leon. So you can use this image for quick revision of which latitudes have which type of climate and what is the pattern of rainfall and temperature in those regions, as well as what kind of forests are found in those regions. With this, we will conclude our video. This was my first live stream. I will try to do more live streams and take your questions. Remember, you can use all these codes over here for asking the questions. If there is any problem, do write in the comments. I will check them. If there is any problem in the configuration. I hope you have liked the video. Do share this video with your friends. Thanks for watching the video.